In this part, I'll take you through a comparison between structures and classes, which I think is important as a programmer to know the differences and similarities, because then you would know when is the appropriate time to use a class and when is the appropriate time to use structures. So let's take a look and do a quick comparison. First, we'll look at the similarities between structures and classes. The first similarity is that both structures and classes define properties to store the attributes or store values. Both of them can define methods to provide some sort of behaviors or actions. And both of them create instances. So you can have an instance of a class, you can have an instance of a structure. Both use dot notation. So whenever you want to update the value of a property or output the value of a property or call a method, you would use dot notation. Both of them use initializers or init methods to set up the initial state of their properties. Both of them can be extended to expand their functionality beyond a default implementation. Now, extensions to a class or structure will be handled in more detail in the final lesson, which is lesson 8. So if you don't understand this point, it's okay. We'll defer this point to lesson 8. Another similarity is that both of them conform to something called protocols to provide standard functionality of a certain kind. And here again, protocols is something that we'll deal with in the last lesson, lesson 8. So let's also defer that part to lesson 8. Now that's where the similarities end, because there are huge differences between structures and classes. The main difference is that classes have inheritance, or inheritance can be enabled in the class. We have a parent class and you have a child class. But structures don't take part in inheritance, which is actually a disadvantage, because one of the reasons for having inheritance is to be able to inherit all the properties and all of the methods from the parent class. Therefore, you have code reusability. You don't need to rewrite the code. Unfortunately, since structures don't have inheritance or can't play a part in inheritance, they don't benefit from this advantage of being able to reuse the properties and reuse the methods. So big disadvantage with structures. Another difference between structures and classes is that classes enable something called typecasting, which enables you to check and interpret the type of the class instance at runtime if the type of the object is not known at compile time. In structures, the type needs to be known at compile time. Let me just quickly explain what the difference is between runtime and compile time. When you as the programmer write the code in Swift, your device doesn't understand Swift. What will have to happen is the code needs to be compiled from what we call source code into binary code. And this compilation happens at compile time. This is done by the programmer, where the Swift code is broken down or reduced or transferred or converted to binary code. This is at compile time. Runtime is when the binary code is actually executed on a device. When the user is using your application, that is called the runtime. Well, so now you understand the difference between runtime and compile time. Now, the second point I'm trying to make here is that sometimes the type of the object or the class is not known at compile time. With classes, this is possible. You don't need to know the type of the object at compile time. You can determine the type of the object at runtime. Only classes allow you to do this. It's called typecasting. But if you're using a structure, you need to be sure that of the type of the object at compile time. You cannot defer finding out what the type is going to be at runtime. Structures don't allow you to do that, but classes do. So that's another advantage of classes. Classes can also have something called deinitializers to enable an instance of a class to free up any resources it has assigned. So we could assign the value of nil to a class. Yep, that's another advantage. But structures don't have something called deinitializers. Let me use a simple example. In classes, if you put in a value into a property or create a class and you initialize that class, if you don't need that class anymore, during the course of your program, you could empty the class. You could deinitialize the class and release that memory space for other parts of the program to use it or other apps to use that memory space. So classes allow you to do something called deinitialize. But if you're using a structure, if you initialize a structure, you cannot release any of that memory during the course of the program. You'll have to wait until the user ends the app or exits the app, then that memory space will be released. That's another disadvantage of using structures. Another advantage of classes is that classes allow you to do something called reference counting, to enable more than one reference to a class instance, what we call pass by reference. Unlike structures that copy values and do something called pass by value. Now this is a very important concept. Pass by reference and pass by value. And in the next part, which is part D of this lesson, I'll be spending a whole part of the lesson with some examples to explain this very important concept in programming called pass by reference and pass by values. For now, just know that classes pass by reference and structures pass by value. And I'll explain that more in the next part. Now, what are value types? Okay. A value type is a type whose value is copied when it is assigned to a variable or a constant, or when it is passed to a function or method. So for example, if I have a variable called num2 and I have another variable called num1 and I say num1 equals to num2, if that's a value type, then the value of num2, a copy of it, will be made and put into num1. That's what we call value types. Now by default, all of the basic types in Swift, integers, floating point numbers or double, booleans, strings, arrays, and dictionaries are all called value types. Even structures and enumerations are value types. Now, what are value types? When new variables or constants or instances are made, they are stored on the data segment or the stack segment in the RAM. So by default, integers, floating points, doubles, booleans, strings, arrays, dictionaries, structures, and enumerations are called value types by default. If you do want them to be passed by reference, then you need to explicitly use the in-out and the AND symbol. And we did a few examples like this in the earlier lessons where we used in-out and we used the AND symbol. But if you don't understand value types, again, I will spend a whole part for you in the next lesson, the next part of this lesson, to to explain more about value types. The opposite of value types is reference types. Okay. Now, what are reference types? Reference types, when you're moving one variable into another variable, you're not actually making a copy, right? What you're doing is you're passing a reference to that variable, or you're passing the address of that variable, or in Objective-C we used to call this pointers. You're passing a pointer to an object, or you're passing a pointer to a variable. Okay. Now, reference types, where do they store their instances? They store it on the heap in RAM. So reference types are stored on the heap, while value types are stored on either the stack segment or the data segment in RAM. Now, here's something that's really, really important. By default, all classes are reference types. So if you want to make a copy of an object, by default, all classes are reference types. But if you do want to make a copy of the object, or you want to pass by value, you need to explicitly instruct the program. Now that you know the difference and similarities between a structure and a class, I'll give you some pointers on when to use a structure and when to use a class. So you normally use a structure when its primary purpose is to encapsulate a few relatively simple data values. Okay. Like that example where we did the triangle with the base and the height, and we did the resolution, which was the width and the height. A structure would be most appropriate there when you want to encapsulate a few relatively simple data values. And if you'd reasonably expect that these encapsulated values be copied rather than referenced, it's better to use a structure. And if you know that you don't need to benefit from inheritance of the properties or the methods, and you don't really need inheritance, then rather go for a structure, which is less complicated. When do you use a class? Okay. Normally you'll use a class if you would like to benefit from inheritance, because only classes have inheritance. When you want to reuse some of the code. Another good reason to use a class is that since classes are passed by reference, they make more efficient use of RAM, saving space by only having a single copy or one copy of that particular instant that's stored. Unlike pass by value, where a copy is made, a duplicate is made, which takes up more space. So classes are preferred if you're only going to have one copy of an object, and when you do want to share that copy, you don't make copies of it. You just pass a reference, or you pass a pointer, or you pass an address to that object that's stored on the heap. Now, I know that was a lot of theory to cover without some practical examples. I'm going to, in the next part, the final part to this lesson, I'm going to use practical examples to explain this very, very important concept of pass by value and pass by reference. So it'll become clearer to you. And it's not just a whole lot of theory that I've been talking about. Let's put that theory into practice with the next part when we deal with pass by value and pass by reference.